Consider the passage containing question 10 to 12. The write-up is here. Let me read that first. It says a narrow beam of monochromatic light of wavelength lambda emitted from a source of power P is propagating in the positive x direction after reflecting from a perfectly reflecting mirror which is having this as its area vector. The beam falls on a metal plate of surface area A placed in parallel to the xz plane. So here this picture I have drawn for these wordings. Further says work function is denoted by phi, photoelectric efficiency is eta, photoelectrons emitted from the metal plate are immediately removed from the vicinity of the plate, so they are not there. We need to answer these questions. So situation is this is mirror. Let's say narrow beam of light is coming along the x-axis. It strikes this area vector direction of this mirror is in the minus I cap plus j cap. So this will be 45 degree. Then you'll find this is also going to be a 45 degree because of the laws of reflection. So this line will become vertical along the direction of y-axis. And here this metallic plate is placed which is in the zx plane like this. So I have drawn only two-dimensional picture. These light rays hit this metal plate, so photoelectric effect takes place. Electrons are being generated, they are being removed. That's the situation. Question number 10th, a part of this passage says reflection from the mirror changes momentum of photons and exerts force on the mirror. We need to talk about these force and momentum. Now we know these photons were moving in this direction plus x, then they turn to plus y, so there is a change in direction, hence change in momentum. Now we know momentum of photon is given as h by lambda. Initial momentum is going to be in I cap direction, final momentum is going to be in j cap direction, so change in momentum of photon is going to be final momentum minus initial as a vector, so it's going to turn out to be h by lambda minus I cap plus j cap, and there are two options dedicated for it, so minus I cap plus j cap is going to be the right response. That is option A. Then we need to read the force on this mirror. Now the change in momentum of photon, if you look at, so that change in momentum is in minus I cap plus j cap direction. That means in this direction, so this direction is the change in momentum of photon. So if we write the force on the photon, that is going to be in the direction of this change in the momentum. And we know whatever the force photons are going to experience, the same force is going to be experienced by the mirror as well, but in opposite direction. So direction is going to be opposite to this. That means if we multiply with a minus 1, so it will whatever the direction is going to get, that will be the direction on which the force is going to act on the mirror, because it's asking force on the mirror. So you see force on the mirror will be in opposite direction to the change in momentum vector that we have calculated. And we know the force is going to be basically rate of change of momentum. So since this is momentum, rate of change of momentum means if we multiply by n, which is the number of photons falling per second. So h by lambda into this was the change in momentum of one photon. And if there is n number of photons falling per unit time, so this will become the force acting on the mirror. I have multiplied with minus 1 as well, so direction is now I cap minus j cap, if you got it. Now, so this is nh upon lambda. Now you can multiply by c upside and c downside. hc by lambda is energy of one photon, nhc by lambda is the total energy per unit time. That's called power. So we can write this as a power divided by c, which is speed of light, I cap minus j cap. So you'll find the net force is going to be P by C, I cap minus J cap, which is C option. So option C will be marked. So A and C are correct for this 10th problem. Let's move towards 11th problem. Problem reads, after a time interval of delta t, from the instant the light falls on the metal plate, electric field at point very close to the metal and far from its edges is explored. Which of the correct statement is about that? So this is the metallic plate, and it will be positively charged because electrons or photoelectrons has been emitted. So negative charge has gone, so positive charge is left. And since this conductor, it will be uniformly distributed, and if we catch a point very close to this and away from the edges, so that point will be like experiencing that it's very large plate, and the field is going to be in this direction, and this field is going to be following the formula like sigma upon 2 epsilon naught. So we need to find the sigma, that is charge density. So for that sake we need to find charge. So after delta T, charge on the metallic plate can be calculated by using this expression, which is Q is equal to N dash E, where N dash is representing the total number of emitted photoelectrons. And we are going to write this a positive E because this charge is positive. Now photoelectric efficiency says eta is equal to the number of photons, photoelectrons that are being emitted divided by number of photons incident. Now n is the number of photons incident per second. If there is a delta t time, then you'll find the number of photons emitted is going to be n delta t. So these are the total number of photons. These are going to be total number of photoelectrons. So from here we got to know that n dash is equal to eta times n into delta t. These numbers are known to us. Now we also know that the power is given by nhc by lambda. So from here n can be calculated, which is p lambda divided by sc. Now n is the same number, which is incident photons per second. Now put this n value on this, so n dash comes out to be this, which is eta p lambda upon sc into delta t. Now once we got this n dash, we can find the total charge, and once we find the total charge, we can use this formula. So this formula for electric field goes to Q divided by 2a epsilon naught, because the sigma can be replaced by Q by a. So Q upon twice a epsilon naught, because a is the plate area and that is known to us. Now Q can be replaced as n dash E, and there is a twice a epsilon naught. N dash is this number which can be substituted over here. So it turned out to be eta p lambda E delta t divided by 2 epsilon naught sc into a. This is found in the option B. Hence option B is going to be the correct. Option A, B, C, they are talking about the similar things. I mean, that's about same thing, which is electric field. So B is found to be correct. So A and C won't be the correct. D says electric field increases linearly with time in starting and reaches saturation after a short while. So you say that this if electrons are getting away, being removed. So then you'll find the electric field will be given by this expression. And this field is linearly proportional to delta t, of course. Since we are removing the emitted electrons, so this formula will keep on acting for a long time, So in short while it comes into saturation, that doesn't suits it. Okay, so option B is the right response. And then there's finally question number 12 is also associated with the same. And it says that if the power of the source, wavelength of light, surface area, photoelectric efficiency of the metal are adjusted to these values, that means their values are known to us: 60, 600 angstrom, 0.04 meter square, and 10 s per minus 4. Along with this, it also gives us the value of SC. Then we need to say about options A, B, C, D. So we need to read each option carefully. It says the range of kinetic energy of photoelectrons does not depend on the photoelectric efficiency of the metal used. So we know the range of kinetic energy of photoelectron is from 0 to K max. So the range will be affected by K max. And we know this K max is given by this Einstein equation, which is SC by lambda minus 5. So these numbers are known to us. That means this number is going to be a fixed number. And this is independent of the photoelectric efficiency. So this range does not depend in the photoelectric efficiency. That means A option says correctly. Then come to B. It says if the work function of the metal is given to us, then maximum kinetic energy is going to be this. So basically we need to solve this equation. So for B, we are going to solve the same equation. And SC by lambda can be written as SC is 12,420 and lambda is 6,000 1000 angstrom. So this will come in electron volt, and this work function is given as 1.9 electron volt. So this turn out to be 2.07 minus 1.9. That ultimately comes out to be 0.17 electron volt. You can check these calculations. So option also says maximum kinetic energy goes to 0.17 electron volt. Yes, hence option B is also correctly written. Further, C option reads, if material of metal plate has work function 2.1 electron volt, no photoelectrons are observed. Now you see this incident energy, which is Sc by lambda, we have just calculated in the above option, came out to be 2.07 electron volt. That means this is the amount of light energy or photons energy which is incident on the metal. If this energy comes out to be or falls shorter, smaller than the work function, no photoelectric effect will be observed. And this is 2.07, and the work function, if we assume to be 2.1 for a metal, this metal will not allow any electron to come out, because it will require minimum 2.1 electron volt energy for electron to detach from the metal. Hence, no photoelectron will be emitted. That means photoelectric effect will not be observed. That means option C is also correct. Then last option says number of photoelectrons emitted per second is going to be this number. We need to check. So number of photoelectrons emitted. We know the power is given by Nsc by lambda. And efficiency, photoelectric efficiency is n dash upon n, where n is the number of photons per unit time. So n dash is going to be the number of photoelectrons emitted per second. That means n dash we need to find out. So number of photoelectrons emitted per second is n dash, which is going to be eta time n. Now n can be rewritten from here. So this is P divided by Sc by lambda. Eta is known to us 10 raised to power minus 4. That's efficiency. Power is given as a 60 watt. So that's 60 watt. Now Sc by lambda we have calculated 2.07, but it is in electron volt. So convert it into joules. So multiply 1.6 into 10 raised to power minus 19. Now this number can be simplified. Once you simplify this number, it comes out to 1.82 into 10 raised to power 16. And by the way, same is given in this expression. Hence, option D is also correct. So for this question 12, we will find A, B, C, and D. All options are correct. So we will mark all of them. That's how this passage is completed. Thank you.